Right. Let's do the fifth MCQ here. So fifth MCQ is actually right. Let's see the question. So fifth MCQ is actually from the, it's regarding the pH and also, yeah, it is just a kind of, let's say, somewhere around physical chemistry part, right? Around physical chemistry, let's say like ionic equilibrium, right? So around ionic equilibrium part only you have, they are asking about the pH and also they have given about the pH something, right? Now see here. So we have 70 centimeter cube of 0.1 mole of aqueous HCl solution. Okay. Now what we have is, now we have a 70 centimeter cube solution of 0.1 mole decimeter minus 3. Right. We have HCl solution. Now you have HCl aqueous solution. So this is aqueous. They are given in the question itself. Is mixed with, right, now they are mixing this one with 30 centimeter cube of x mole decimeters minus 3. They haven't given the concentration. So 30 centimeter cube of x mole decimeter minus 3. I have written capital M. You can write mole decimeter minus 3 in terms of capital M. No harm, right? I have written in this way for my easy simplification, right? Nothing to get confused here. Capital M term means you can write for the concentration also. So x mole decimeter minus 3 of in a solution. If the pH of the resulting solution is 2. Now after mixing, you guys tell me what will be the total volume. Right. You are right. Actually, it has to be 70 plus 30, right? The volume is going to be 70 plus 30, which is equal to 100 centimeter cube. So this is going to be a resultant solution's volume. Keep in mind, don't do stupid stuff while you are doing this, while you are doing the calculation part, because most of you will get error here. Keep in mind, these first 10 MCQs, never try to lose any 1 mark, right? If you are losing 1 mark here, keep in mind what kind of a person you are. It's actually the easiest one, right? So around 100 centimeter cube is there in the resultant solution, right? And they are saying this solution's pH is actually 2. This solution's pH is actually 2. Now the question is, the value of x in mole decimeter minus 3 is. Now we have to find out the concentration of x. Okay. So this is your raw idea. So what I am going to do is, I am going to simplify this thing completely here. Right. Let me give an idea here. Okay. See here, you are mixing them up. And the final resulting solution is 2. Now see here, you have to think carefully, right? You have to think carefully. Now once you are saying the resultant solution is pH is 2. The meaning of 2 means in pH means it's acidic. So what has happened actually here? If pH is 2, you have to keep in mind something is going to be excess between these two reactants. You have NaOH and HCl. NaOH is actually a base, right? NaOH is a base. HCl is also HCl is an acid. But once you are considering the strength of these two, both of them are strong cases. You have strong base and then you have strong acid, which means that completely both of them will completely dissociate H plus and OH minus in their respective aqueous medium. That is what Bronsted-Lowry theory said. Right? Bronsted-Lowry theory said, I mean, not Bronsted-Lowry, sorry, Arrhenius theory, right? Arrhenius theory said the person or a substance that is able to, not a person actually, sorry guys. So, the substance that is able to completely release H plus and OH minus in their respective medium can be said as strong base and strong acid respectively. So, this is actually there in the ionic equilibrium part. This is actually in the ionic equilibrium part. Okay, now let's come to the point. So, pH 2 means it's actually a strong acid here. Okay, so what will happen is now we have HCl reacting with NaOH to give NaCl plus H2O. You have studied this also in the O levels, same reaction, right? So you have to think about the number of moles that was there present initially, right? Now see here, initial, you have to find out the initial moles. So let me write here the initial moles. Initial moles. So for the initial moles, see here guys, very easy. So you know N is equal to concentration of a substance with the respective volume. So the number of moles of HCl that we had is equal to, we have 0.1 mole decimeter minus 3 into 70 into 10 to the power minus 3 decimeter cube. Convert them all to their respective units. That will be easy to cancel them out. Right. So I'll get 7 into 10 to the power minus 3 moles. In the case of NaOH, you have X mole decimeter minus 3 into 30 into 10 to the power minus 3 30 into 10 minus 3 decimeter cube. So the answer is going to be 30x into, right? It's going to be capital X, right? You guys get confused, so I'll use simple X here, right? Simple X, right? X into 10 to the power minus 3 moles. Let's bring it here. So I said resulting solution's pH will be 2. Yeah, our pH solution is actually 2. pH of the resulting solution is actually 2. Right. So initially we had 7 moles. 7 into 10 to the power minus 3 moles. And initially we had 30x into 10 to the power minus 3 moles. So initially there is nothing here. So here you have the initial cases here. Okay, now be careful. Now we have to go to the reacting moles. Okay, here comes the deal. As I said, pH is going to be 2. So if pH is 2 mean it is actually acidic. So therefore, will any base will be remain? No, the base will actually will be completely destroyed. The base is actually completely destroyed here. There will be an excess of HCl. That's how pH became 2. You understand how pH became 2? Here NaOH is going to be completely eliminated. So who is going to be the limiting reagent according to the chemical calculation? NaOH. Why this cannot be an equilibrium sign? Why? Because you are going to use strong acid and a strong base. So that's how you are going to get this reaction. Is NaCl kind of a neutral or acidic or basic? You can say this is neutral. Why? Because you're using strong acid and a strong base. This you have studied in the physical chemistry part. What kind of a salt is this? This is actually a neutral salt. This doesn't do anything to the resulting solution. Understood? So this is the main thing here. So never get confused here, right? So what will happen is you are going to get a limiting reagent case here in this case. So you have minus 30x into 10 to the power minus 3 moles, right? So here also you're going to get 30x into 10 to the power minus 3 moles by Baba case, no. Montessori. Here one. So 1:1 ratio, stoichiometric ratio. So minus 30x mean here also minus 30x. The same thing will come here. I'm not coming to this part because these things won't affect the resulting solution. So I will just neglect this out. So finally you have the right. See here. Sorry for interrupting. So the resulting solution here you have a limiting reagent 0, right? You have 0. So the remaining is going to be of this HCl is actually 7. I can just take 10 to the minus 3 in common. So 7 minus 30x into 10 to the power minus 3 moles here. So this is going to be your remaining moles, and as usual I no need to write this part since this is an MCQ part. You can just take commonly here, like let's say, let me write it out. Maybe some of you might get confused why is in writing, right? So this is the thing here. You will get 13x into 10 to the power minus 3 moles here. All this thing will come again down, right? Moles, and here also plus 30x into 10 to the power minus 3 moles here. Okay, keep in mind, right? So now this is the main thing we have to consider. This is the main thing we have to consider, right? This is the main thing that you have to know, that the remaining solution and who is the limiting reagent. So our limiting reagent, let's say LR limiting reagent is actually NaOH. So our limiting reagent is actually NaOH. Okay, so our excess fellow is actually HCl, who is a strong electrolyte, or you can say a strong solution or strong acid, right? So this will completely dissociate, giving H plus and H plus in the aqueous solution. Keep this number of moles remaining in your mind. Okay, now let's come to this part. What I'm going to do is, some of you know maths, right? So I will do a thing here. I consider the whole system here as Y. I'll take the whole expression in terms of Y moles, right? I'll take the whole expression in terms of Y, because if I bring this here there, you will get confused maybe. So I'll be using this term, or what you can do is bring this thing and bring to the reaction that I'm going to do, right? So see here. Now see here. Right. Now see here. Currently we have HCl aqueous which is in excess. As I said, this is a strong electrolyte. This will break.